Welcome back to my channel. Today I will be talking on summarizing data using PROC means. We can begin by running PROC means with all the defaults using the permanent SAS dataset blood. By default, PROC means produces statistics for all the numeric variables in the input SAS dataset. Looking at the output, you can see that the default statistics are produced, which are n, which is the number of non-missing values, the mean, average, the standard deviation, minimum and maximum. You can control which variable to include in the reporting by simply supplying a where statement. Here I am showing you the partial list of PROC means option most commonly used in clinical SAS programming. Beside these statistics, the option maxdex equals to value is especially useful. This value controls the number of places to the right of the decimal point that are printed in the output. Let's see the effect of adding a where statement and requesting specific statistics with PROC means. We now only have the statistics we requested on the variable listed in the var list. Notice that all the statistics are reported to one decimal places due to the max dex equals to 1 option. Unfortunately, the number of decimal places we choose to apply is applied to all variables. If we need more control over the printed decimal values for each variable, we can use the proc template. Let's see the effect of adding a by statement to proc means. If we want to see descriptive statistics for each level of another variable, we can include a by statement, listing one or more by variables. Remember that we have to sort our data before and set by the same variable or variables we listed in the by statement. Here we are using the gender as the by variable, and we can see that the output are produced as one for female and one for male. Proc means let us use a class statement in the place of by statement. The class statement performs a similar function to the by statement with some significant differences. If you are using proc means to print a report and are not creating a summary output dataset, the difference in the printed output between a by and class statement are basically cosmetic. The main difference from a programmer's perspective is that you do not have to sort your data before using a class statement. Here also we can see that when we are using a class statement using the same variable which is used in the by statement earlier, gender, we can see that we have a new column created in the output window under the name of gender instead of having two different output displayed as was the case in by statement. One of the very nice feature of using a class statement, beside not having to sort your data, is that SAS uses formatted values of the class variables. You can use this to your advantage by adding a format statement to the procedure and changing how the class variable groups your data, all without having to modify your original dataset. Suppose you want to see some basic statistics, mean and median, for the two blood count variables RBC and WBC, broken down by subjects with cholesterol level below 200 versus subjects with cholesterol level above 200. See how easy it is to do with a class statement and a format statement. You can use proc means or summary to create a new dataset that contains summary information such as sums and means. This dataset can then be used for further analysis. An output statement tells proc means that you want to create a summary dataset. The keyword out equals to is used to name the new dataset. In this example, you are using the name your output dataset as my underscore summary. Following the keyboard and an equal to sign, you provide a list of variable names that correspond to these values. In this program, the variable mean RBC is the mean of all the RBC's values and the mean WBC is the mean for all the WBC values. You can name these variables anything you want. They are arbitrary. The order of the variables here corresponds to the order of the variables in the var list. If you want to create a SAS dataset but do not want to produce any output printed from proc means, you can use the no print option. If you choose to use the proc summary instead of the proc means, you do not need to print, write the option no print. This is the default setting for this procedure. As we mentioned earlier, you can output more than one statistics in your output dataset. As an example, let's output the mean, the number of non-missing observation, the number of missing observation, and the median. The two variable m underscore rbc and m underscore wbc represents the mean of rbc and wbc respectively. The two variables med underscore rbc and med underscore wbc are the medians of the two variables. N underscore rbc and n underscore wbc represents the number of non-missing variables. Miss underscore rbc and miss underscore wbc represents the number of missing values for these two variables. As a check, notice that n underscore rbc plus miss underscore rbc equals 1000, the total number of observation in the dataset blood. You can ask SAS to create variable names for your summary statistics produced by PROC MEANS. The output option auto name causes the PROC MEANS to create variables names for the selected statistics by using the variable names in the where statement and adding a underscore character followed by a name of the statistics. Because auto name is an statement option, it is followed by a slash in the output statement. Here in the output we can see that we are having the RBC's statistics being separated like RBC underscore mean or RBC underscore N and so on. And same is the case for WBC. There are many uses for summary dataset containing summary statistics on an entire dataset. There are times when you would like to output summary statistics for each level of one or more classification variables. For example, you might want to see ends and means of RBCs and WBCs broken down by gender. Remember that to use a by statement, the dataset must be sorted in the same order. In this dataset, underscore frequency underscore represent the number of observation for each value of gender. It doesn't matter if there are missing values for RBCs or WBCs. For example, you can see that there are 440 females in the dataset and the means for RBCs and WBCs are 5.4 something and more than 7,000 respectively. The variable n underscore rbc and n underscore wbc represents the number of non-missing values that were used to compute these two means. You can use a class statement with proc means to obtain results similar to those obtained using a by statement. The difference between the two become more apparent when you are creating the output datasets. The program here is a repeat of previous program with a class statement replacing the by statement and the proc sort omitted. Notice that now you have three observation instead of two. The first observation in this dataset with underscore type underscore equals to 0 is the mean for both males and female. Statisticians call this the grand mean. The other two observation with type equals to 1 represents the mean of female and male. If you want only the means broken down by gender and do not want an observation with the grand mean in your output dataset, use the n-way option of proc means. Using this option makes the output dataset using a class statement identical except for the values of type underscore type variable to the output of the dataset created by the using of by statement. It is very important to remember to use the n-way option if you only want to see your descriptive statistics at each level of the class variable. Things starts to get more complicated when you have more than one class variables. Suppose you want to compute the mean and the number of non-missing values for RBCs and WBCs for each combination of age group and gender. You place these two variables in the class statement and create a output dataset just as we did earlier with only one class variable. Notice that things are getting more complicated. Even though there are only two levels of gender and two levels of age group, there are 9 observation in the output dataset with the 4 values of type underscore variable. The underscore type underscore equals to 0 observation is the same as you saw earlier. It represents the grand mean, the mean of all non-missing values in the dataset. To understand the other observation in the dataset, you have to know either how to count count in binary or how to use another proc means option, that is the char type. Now let's see the easy way out and rerun this program with the char type procedure option as follows. This may not look any simpler, but it is now easier to explain what underscore type underscore represent. First of all, the option char type, this stands for the character type, causes the underscore type underscore variable to be of character strings of ones and O's. If you are familiar with counting in binary, you will observe that the character string under the underscore type underscore column represents the previous underscore type underscore values, except they are now in binary representation. Here is the rule. If there is a 1 under the class variable, the statistics in the output dataset represents the statistics computed on each level of that variable. For example, if you are computing mean, the mean for with a value of underscore type underscore equals to 10 is a mean computed at each level of gender for all age groups. If you want only the statistics broken down by each level of class variables, you can use the n-way option. This selects only the largest value of underscore type underscore. If you use the char type option, n-way selects the value of type containing all ones. There is an alternate way of selecting which variable and statistics you want in your summary dataset. I have added several new features in this program. Each statistics keyword is followed in a set of parentheses by list of variables for which you want to compute these statistics. For example, this program computes mean for RBC and WBC, the number of non-missing values for all the three variables, which are RBC, WBC, and cholesterol, and the median of cholesterol. Although you can name the newly created statistics following the equality sign as before, this program uses the auto name option to name them. Finally, you may wonder about the rather strange looking drop equals to dataset option in this summary dataset. This drop equals to option uses the colon wildcard notation. All variables beginning with an underscore character will be dropped. In general, name semicolon used in any location where you will place a variable list refers to all the variables beginning with the letter name. You can think of the colon as the same way you use an asterisk in a DOS wildcard. That's all for now. Thanks for watching. Please let me know in comments if you want me to cover any specific topic.